Okay, seems like we are live. But why don't I see anything? Nice, we are live. We are live. Today we are going to continue our wait. MQTT implementation. Workspace. MQTT. So we are. Let me just double check everything is fine. Seems good. Cool. We are here. It says with this amount of wattage, it will only last about 44 minutes. That's not good. Mm. Okay, so where did I left this? I am no C tags MQTT. There's nothing in main. So I guess I'm still implementing this header file. Which, if I remember correctly, that means these things were done and was here. So MQTT connect. MQTT connect. MQTT connect. According to the documentation, where's the rest of it? Okay, so the approach I'm thinking right now is this: instead of figuring out everything at once, what I'll do is I'll do compiler driven development, CDD. What that means is I'll write whatever here is, I'll compile, and the compiler will yell, and only then I'll fix things, because the compiler will be the compiler will decide the direction for me. Right now there's just too much to. But where the heck did that documentation go, man? MQTT. There it is. Cool. I feel like I have to watch my old stream to get sync in, because I think I don't know anything right now. How much battery do I have? 72. Cool. I hope today we are able to code something, because I just said I'm not here to do this document reading. The very first thing I'll do is why did I do that? No corporate message. These linters are just. So this connecting where it is. So this much is done. Next is from now on the definition of other packets are revealed by reproducing the pattern according to the documentation of this. We proceed with subscribe, unsubscribe, and publish. Subscribe is the only packet with a dedicated packet definition. Subback. Last time when I read this, I thought I figured it out, like 80% of it. But now I feel like I know nothing. Like this complete this one sentence doesn't make sense to me. And last time it was piece of cake. What does it mean that there's a dedicated packet definition? Dedicated packet definition. Subscribe. What does subscribe do in here? So so like this documentation is laid out pretty well because every MQTT packet or message, I don't know the official terminology, but it's fixed header, then variable header, then payload, then response. Subscribe acknowledgement. Let's just see. So the subscribe packet is sent from the client to server. Obviously makes sense. Cool. Server can send application message to the client. Cool. The fixed header looks like this. Okay, so this will contain the packet type, packet frame, packet frame field. And I'm just trying to lay down the semantics. So for subscribe, the fixed packet header is the control type. Yeah, this makes sense. This is reserved, and the remaining length will tell me if we have variable header and payload or not. So subscribe. The remaining length. This is the length of variable header. Length of variable header plus length of payload. Now the way the encoding is happening for this remaining length field, I don't understand it yet. The variable header contains a packet identifier. Variable header contains packet identifier. Okay, PID basically. Section this provides more information about packet identifiers. I'm not interested right now. Variable header with a packet identifier of 10. The fuck is non-normative example? What is the meaning of this? Establishing, relating to, or deriving from a standard or norm. Ah, okay. Can't you guys just simply use some normal terminologies like normal words? Can't you use those? Non-related example. What, like, would it cause you some? Would it cost you something to use here that this is a non-relative example? Okay, I've been looking for this definition in this particular document. Cool. So this example is not related to this official documentation or the official protocol. It's just an example. Fine. Thank you. The packet identifier. MSB, LSB. The payload of subscribe packet contains a list of topic filters indicating the topics to which the client wants to subscribe. Indicating the topics to which. Indicating the topics to which. I don't make doesn't make sense to me. Maybe my brain is not at its best today, which I know why. Topic filters, list of topic filters indicating the topics. So just calling it a topic filter, but it's just a list of topics that the client is interested in to subscribe. Fuck. Topic filters in a subscribe packet payload must be UTF-8 encoded strings as defined in section this. Cool. A server should support topic filters that contains the wildcard characters defined in this. If it chooses not to support topic filters that contains wildcard characters, my bad, it must reject any subscription request with whose filter contains them. Each filter is followed by a byte called the requested QoS quality of service. This gives the maximum QoS level at which the server can send application messages to the client. And the payload of a subscribe packet must contain at least one topic filter or QoS pair. Understood? A subscribe packet with no payload is protocol violation. Huh. Cool. So the payload format, how does it look like? This is the topic filter with the MSB, LSB. Okay, so the first 2 byte contains the length, and the rest 3 to n. Where does n ends? It one contains topic filter, basically name. Requested QoS, so from n to 1. QoS, these are don't care. Okay, so these are care, these are reserved. The upper 6 bits of the QoS bytes are not used in the current version of the protocol. They are reserved for future use. The server must treat a subscribe packet as malformed and close the network connection if a reserved bits in the payload are non-zero. QoS is not 20, not 2. Malformed. Okay, close the network. Man, this is harsh. Payload non-normative example. Payload byte format non-normative example shows the payload of the subscribe packet briefly. Okay, so the topic name, which is like A/B, quality of service is 1, topic name is CD, quality of service is 2. This is so good. I don't know why. Topic filter. Byte format, non-normative example. Okay, so this is like example payload that we'll receive, then how this payload will get encoded into the packet. So this is that example. Like how would it look like in this format, this given format. So just filling in the abstract values. The topic filter which will contain, okay, so if the topic name is this and the QoS is this, then how do I form a payload out of this? So the first 2 bytes are going to contain the length of this, so which is like LSB means 3. Then this is A forward slash, this is B. So A is 61, so this will be 16 into 6 plus 1. 16 into 6, so 60 is 36. 60 plus 36, how much 60 plus 36 is? 96 plus 197. So this is okay, so it is UTF-8, so the ASCIIs are in there. So it is ASCII compatible, so this would be 97, whatever this is, this 98, that would be this many. QoS, this is straightforward. Same goes for this, and this is QoS, but this can go for N. I guess this size, I mean, not guess, oh, absolutely this has to be true. And the first 2 byte, like this, that would be 64K. 64K for a topic number is like super good, but like super big, which we may think that we'll never be able to fill. But similar was the case for IPv4, and it got filled. But IPv4 is a different thing than MQTT, so I guess it's fine. Whatever. Response, what the server, when the server receives a subscribe packet from a client, the server must respond with sub. I think I have synced in enough with what's happening. So I'll open this subscribe thing here, and we'll just continue this. So you're saying that we have subscribe and I have not written anything here. Okay, cool. Let's just see. So I define a subscribe, and what do I put in this? Like, okay, so this is fixed header, so it's a common thing, and it contains a packet ID and a tuple length. Short means 16 bit. It is here, right? Fixed header. This is your MQTT header, which is going to be fixed. And MQTT header is MQTT. It's just a 1 byte. Byte 2 is remaining. Fixed header. I mean, this. I'm thinking like this. So this is this is byte 1, right? So this is byte 1. And this is nothing but addressing those bytes by those. You get it. Bits by name. So bit access to name. Then where is this second byte, because it's a fixed header, right? But that depends on the type of this, the type of packet, na. So that means in some packets it will be, in some packets it won't be, which is described like Mqtt control packet format. Here it is. Packet ID. Okay, so what the packet ID is, I think it is relevant to read this right now. So some types of MQTT control packets contain a variable header component. It resides between the fixed header and the payload. It resides between the fixed header and payload. Fixed header comes first, payload comes second, so it resides in between, so it comes between first and second, so maybe 1.5. The content of the variable header varies depending on the packet type. Okay, so that is why this thing doesn't gets contained in every packet type. So the packet identifier field of the variable header is common in several packet types. Subscribe, unsubscribe, and publish control packets must contain a non-zero 16-bit packet identifier. Each time a client sends a new packet of one of those types, it must assign it as it must assign it a currently unused packet identifier. Uh, so the okay, so the client sends a new packet, then the server assigns the packet identifier. If a client resends a particular control packet, then it must use the same packet identifier in subsequent resend of the packet. The packet identifier becomes available for reuse after the client has processed the corresponding acknowledgement packet. The client has processed the corresponding acknowledgement packet. What does that mean? Client has processed the, I don't know. In the case of QS1 publish, this is the corresponding pub back. In case of QS2, this is pub comp. We'll see later. So the control packet is the packet identifier. So these type of packets contain this normative example. Connect requires payload. Payload. Connection act on act. For this, this is a byte and you are addressing it via dot bits reserved. This is session present. I think I should move forward. It's already been too much reading. and I feel like I'll not get anything. Like at this point, I feel like it's a diminishing return by reading the documentation this much, because I certainly don't have any idea of MQTT. I'm just implementing it. So we'll write subscribe. In this subscribe, it is called a header, makes sense, and the packet ID, then the tuple length, so the length of the payload. You can see from here. It will contain a fixed header, which is this, and then this remaining length, whatever that is. You call these tuples, pointer to tuples. Why did you do that? This is the topic length. Where did this come from? What is this inside this? This is my fixed type. I make sense. This I know. Variable length header will contain. It's an example. Packet identifier of 10. Okay, so okay, so packet identifier of 2 bytes, which is this. Then what is tuple length, bro? Then it's your payload. I think these two. So the first one is 2 bytes. Maybe it will make sense later. Let's just write it. Mqtt subscribe. Right. So the first thing is header. Why is it a union? Okay, sorry, my bad. It was defined as union. Mqtt header. How did I? Okay, so this is just a header. See, I forgot everything. Then you like packet ID. Then comes my packet ID when T16 packet ID. Then we are for some reason using this tuple thing, which doesn't make sense to me right now, but I'm gonna write this. What did you name it? You need tuple length. Next is you are truck, basically putting them together and naming it. Struct tuples length topic. So the first 2 byte is okay. So let's just make sense. What do I know already? Here the first 2 bytes. So the payload, for the payload, the first 2 bytes are my length, and the remaining are my topics. The first 2 bytes are length and remaining are topic. How much bigger this is going to be, I don't know. And then comes my 1 byte QoS. 1 byte QoS, right? Yeah. So maybe later I'll change this to something that I'm more comfortable with, because this syntax doesn't make sense to me, like this one. Maybe I don't know yet. Tuples. The first one is going to be my 2 byte length. Did you call it length? Why did you call it topic length? I mean, it's a subscribe, so uh, for the time being, topic length and unt 8-bit. This is your, and this is okay. So it next thing is going to be my topic. 1 byte QoS. Is fairly uncomfortable today. I think I get it why this tuples is there. You remember the example? This one? Like, like this. It could be more than one tuples, more than one topics, right? And for each topic, this is like fixed. Like there's going to be two things. What first one is topic name and then the QoS. So if I'm having like n number of topics in a subscribe packet type, then I could have more than one. So like in this case, I have two of these, each of these type. I think this is what that tuple length is. This guy. I think this is why we have this, because this will tell us how many these are going to be, because everything is going to be a length, like how big how big this topic string going to be, and then it's QoS. Makes sense, right? So this one is for this is everything. So this is one tuple. So this guy just called it tuples. We could call it something else, but for now, naming is our least worry. I think this is why we have this tuples. I think. I think. Okay, let's move forward. Cool. So this is done. Okay, so is this Control Shift I or what? If I do this, it will already format it like this. So what is this? It belongs to struct Mqtt subscribe, which is of unnamed type, and the type is this is the name. It's not a type. So this is what I'm trying to figure out. Like if this tuples is it's a variable of type this. It's a pointer to this. It doesn't contain ebro tuples. Now we have unsubscribe. So what does unsubscribe say in this? Unsubscribe here. So unsubscribe, but I did not. Okay, so the response is a separate thing. Sub we'll see what the response is. Let's just implement what we have in hand first. So right now this is next. This unsubscribe is next. How it is going to be? Unsubscribe is sent by the client to server to unsubscribe from topic. It is going to be a header. It is going to have a header. So if I go by this convention or what I have already trect unsubscribe qt header, and same thing. Do you think this is going to have a packet ID or not? I mean, this depends. Like, okay, so the variable header does have a packet ID. Okay, so pkt id what tuple length is there an example? Yeah, so the topic is this. So unsubscribe me from this topic and unsubscribe me from this topic. There is no QoS. So I think that we are going to have, okay, so the tuple length, okay, already covered. So 16-bit is going to be for what is the length of what? Topic length, I guess. Okay, so yeah, topic length. My bad, bro. And the actual topic. There is no QoS, and how many these are. Okay, I think it makes sense to me now. And I can't convey what makes sense to me because it it's obvious to hear this. And what made sense to me, I'll just tell you, is that this is a blueprint. Like we all know, like classes are blueprint, and structures are blueprint. So that by blueprint we mean that this mqtt unsubscribe or this data is not in the memory yet. It's just a template, blueprint, whatever you want to call it. So whenever we instantiate something of this type, only then it gets into the memory. So having said that, that means this packet id thing, all of this. So okay, so what I thoughts are moving very fast. So my point is this star. Why do we have this star? This is because the same reason we have star here. I'll tell you what my brain thinks is that this tells me this is the length. This tells me from this address I have this much memory consumed or owned or whatever. Similarly, from this address I have this much memory consumed or owned. So topic length, topic, tuple length, tuple, pointer. So yeah, that's very raw. That's very beautiful actually. Pointers are dangerous, but they are beautiful. Okay, so the unsubscribe is done. See, this is why I like to put it here, here, not here, because this is the type. This is a simple variable. So I'll just go a little sidetrack from this because we are already on this. I like this thing. Let's just say this is some function and it takes a pointer to integer a and pointer to integer b, and it does something something something. A card to, okay, so it does something something. Seriously, so it does something something. So, or maybe I could have said this: integer a contains some address b, right? So why I prefer this star here and not here? Why? Because this says that this is my variable. Because let's the syntax is like this: the type comes here, then comes name, then comes some value abc whatever, right? So that is why this is a simple variable. You don't access it anywhere like this. You only access it like this, and then you do this, right? So that is why I like to put it here, because this tells me that this is a type, and type, it's not an integer, it's a pointer. How? Because of star. And this is just a variable like regular variables, not regular variables, but you get the point. So it's a plain looking variable, just like a, just like b, and just like a. So I don't know, it just feels very good. And just these things are heavily opinionated, but technically this makes more sense than this one. Anyways, back to the coding part. So MQTT unsubscribe. Okay, oh man, these are tongue twisters for me. Next comes your unsubscribe, then comes your subback. Let's just see what the subback does. Okay, where is subback? So it has a fixed header, variable header, and payload. Okay. subscribe acknowledgement. What does that mean? That means a sub-ACK packet is sent by server to the client to confirm receipt and processing of subscribe packet. A sub-ACK packet contains a list of written codes that that specify the maximum QoS level that was granted in each subscription that was requested by subscribe. The fixed header looks like this. If I go by this, then it's a variable header with some packet identifier. Then comes the payload, which only contains written code. So the example, is there an example? Payload non-normative example. Success QoS 0, maximum QoS 2, failure 128 byte format. Why is it a 2 byte packet identifier? Allowed return code as 00 success. What is this maximum QoS? I don't make sense. Here you have fixed this, then the remaining length. Why these two are set? Is being acknowledged. We will formally illustrate the format of packet ID, MSB, LSB. Payload contains a list of return codes. Each return code corresponds to a topic filter in the subscribe packet being acknowledged. The order of return codes in the sub packet must match the order of topic filters in the subscribe packet. Return code field encoded in a byte in payload. Okay. I just started. I just start typing. So this is your sub packet. So MQTT sub packet, and this will GDER header. Will it contains? It does contain a packet ID. So UNT, will it be similar to that? And next is it contains the payload. Which is of single byte. So can I say just like UNT how does this implement? Header packet ID RCS length. What is RCS? Don't understand. Is there any link payload format? 3.26. The same page. Success maximum QoS 0, maximum QoS 2, failure is 1.8. The order of written codes in this. Okay, understood. So these are for the subscribe topics that a single client send in one subscribe packet. Remember, a subscribe packet can have multiple topics. So this is for topic, for each topic. So for topic 1, this was the written code. For topic 2 and for topic 3. So that's why it is like that. So I think this is the reason, and this is the byte order. So the first byte is this, means everything is 0. Success maximum QoS 1. Zero one, and maximum QoS failure 128. Payload pack, subac payload packet. So these two. Why are they X? What does that mean? Subac return codes other than 0, 1, 2 and 80 are reserved, must not be used. Codes other than 0, 1, 2 and 80 are. So apart from those, everything else are reserved and you cannot use those. Okay, so a topic can have multiple acknowledgements. That means a return code is string length. String length. I think this is what that means. And that would contain the order also, because it's not just a single payload, just a complete length. I think this makes more sense. 16-bit, yeah, because return code is string alien. I'm not a. But I'm not sure if this is true for this. I mean, this is what this acronym means. So I'll stick with whatever that is written. So return code is string alien. I guess, I hope it is that, and then the character. Unsigned character. My god. RCS. It. Subscribe. Cool. Payload, you this does not have a payload, it have RCS. Now the publish. What do we have in publish? Pub 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 pub, pub publish. Publish is here. Publish packet is pubback. Bro, I said publish. Publish here na. Mqtt publish. So publish control packet is sent from client to server or server to client to transmit an application message. Yeah, server also publishes to client. It doesn't use notify or things like that. It just sends it. using publish packet type. So the fixed header is this, all of this set is in the fixed header, then the byte comes this. You know why I speak so bad? Because I just can't keep up with my thoughts. I'm thinking one thing, I'm saying it, then I move on to the next thing on my thoughts. So just a mess when it gets out of the mouth. Publish. Oh God. Mqtt publish it is right. Yes. Yeah. Where are we? Yes, it's a simple one. Header, then we have remaining length, which is it just saying whether duplicate. I think this will get covered in that control packet type. QoS non-normative exam, non-normative comment. Okay, so the recipient, just bad. The recipient of control packet that contains dupe flag set to 1. Recipients of control packet that contains dupe flag 1 cannot assume that it has seen an earlier copy of this packet. What does that mean? No idea. The dupe flag must be set to 1 by client or server when it attempts to re-deliver a published packet. The dupe flag must be set to 0 for all QoS 0. That makes sense. QoS oh okay. Variable header contains the following fields in the order: topic name, packet identifier. Topic name, packet identifier in the so the variable header hmm topic name and then packet identifier. I just see what is happening here. So for publish you have packet identifier, topic length. I think when he's serializing these packets, like when you instantiate this and then you serialize it, only then it matters that where is this thing is. And then only then the order matters, because I mean easier would be to just use the layout also in here, but maybe we'll see later, because as per this it says that there must be as the first field in the publish packet variable header. Packet ID, it says topic name must be first field, but here topic. Yeah, when the serialization क्योंकि ah, understood. This is lang, this is the pointer to address, so I cannot order these, right? So the serialization will take care of this order. So if I have to make sense of this and to encode this value in my code, I have figured this fixed header. Then comes this variable header that will contain topic name and packet identifier. So topic name will come later. I'll use packet identifier first as per this. So unt 16 pkt id, then comes my topic length, and then your actual topic, payload length, payload topic. Why is it? Variable header comes packet id, packet id is just 16-bit, right? Topic name, packet id. So the publish packet variable header. Okay, variable header will look like something. 2 byte goes for this, and then this. Payload contains the application message that is being published. The content and format of the data is application specific. The length of the payload can be calculated by subtracting the length of payload is subtracting the length of variable header from remaining length field that is in the fixed header. It is a valid for published packet to contain zero packet length. So the length of payload would be subtracting the length of variable header from remaining length. The remaining length minus variable header is your payload. I think that is why it's just so simple here, that payload length is this and the actual payload. And character t. Wait, I've been typing wrong for this whole. Mqtt unsubscribe. Mqtt. So back. Mqtt publish. Did I use anywhere else this egg thing? Okay, so the connect is this. Should I change this too? I mean, it is a different word, so back. It was looking good actually, but just for the consistency, I'll keep it. No, no, not at all. Then comes your payload length is fine. Publish is done. Then I have mqtt acknowledge, which is subscribe, we proceed with this and this, and subscribe is the only packet that with a dedicated packet definition. The other can be defined as generic ACK and type named using type def for semantic separation. Generic ACK, so that is the generic ACK. All right, so sub ACK, connection ACK, and that was defined here. And this is the header and then the packet ID. These are generic ones. Okay, makes sense. MQTT ACK. MQTT looks weird. Packet ID. Could not find a new line character, and I just go with this, bro. Remaining ACK packets, namely PubACK, PubReg, can be okay by type tapping struct ACK. Just for semantic separation of concern, the last one, disconnect, is not really an ACK, but the format is the same. ACK, MQTT. This with this I'll copy paste because uh, unsub ACK. Hmm. Disconnect. So and did something change? This MQTT header is your ping request, ping response, disconnect. MQTT header is your disconnect, ping request, ping response, request response. Then your MQTT ACK is your MQTT's unsub ACK, and your pubcomp, whatever that is, pubdel and fine. We can finally define a generic MQTT packet as a union of previously defined packets. A generic MQTT packet as union of the previously defined packets. Okay. Oh boy, this is so good, man. This is clever. I know my. Okay, so I understood. I'll tell you what I understood. I'll pick the very first example of this here. Why is it helpful? A integer, sorry, a byte and a byte, right? Like 4, 5, 6, 7, 8. So this whole thing is a byte, and this is a byte. So why is it useful to define it as a union? Because I know from this union, I'll use either this or this. I'll never use both of them at the same time, right? So if I want to address this as byte, I'll do this. If I want to address this as bits, I'll do this. Now, the byte was already defined in the computer, right? So the 8 bits there already. So the data type is just predefined, primitive ones. Similarly, data types are primitive ones like 8 bit, 8 bit, 8 bit, 8 bit. Now the real power comes here, not here, here. So what he said is, what he did is he defined a MQTT packet, and I know for sure that my MQTT packet, when I'm sending any one packet, like in protocol, I send only one packet at a time, right? If I'm publishing, then the control packet is publish. If it's a connect packet, then it's a connect packet at once. So if I define a union here of some type, of some name, let's just say MQTT packet, then I know for sure that it is going to be either one of them. So in later part in the code, I can basically polymorphism it. How? I'll wherever I'm expecting a MQTT packet type in a function or something, anything. I'll just type it. I'll first do this MQTT packet. Okay, so let's just copy this. Uh, is it MQTT? I don't have a. Yeah, so I was saying that I'll in later in the code I just say my function is something like this. I just say there is some function which does something, and I know that this function can take for the time being forget that this exists. Let's just say this function operates on MQTT packet type, right? And there could it works on every packet type. So it works on acknowledgement, it works on MQTT connect, it works on MQTT publish type, unsubscribe, all those control packet type. Then I could say I could do this via pointers. Like I can say that this is my MQTT packet generic pointer and pass in something like this, right? Or I can simply say, oh, my bad. So right, so I can do this, or I can say this, because this will take only the greatest member size. Like, so if let's just say if publish has the greatest member, then it will take only this much size, and I can pass it around. And inside this function, I would always be known like which type of this is, right? So there would be some mechanism to know that. So something like this. I may be wrong. I'm just extrapolating from this, because this is, I think I could use it somewhere. This is pretty handy. The thing that strike me at that time is this. Uh, we were already doing this union thing for bytes and all predefined data types, primitive ones. But I realize that if we do this for the user defined data type, that complex ones, then it is actually really powerful, because this is good. Cool. We proceed now with the definition of some public functions. Okay, cool. So everything was in mqtt.h, right? Yeah. Public functions, here in the header we want to collect only those functions and such structure that should be used by other modules. To handle the communication using MQTT protocol, we need essentially 4 functions. Cool. 2 of each direction of the interaction between server and client. A package packing function and unpacking function, serializing or marshalling, deserializing or unmarshalling. Why? Just use this. I won't dive here in dissertation on the correct usage of these terms. Seriously, there is some essay, thesis, paper, study, composition, discourse, assessment, discussion, criticism, tract, monograph. I think I get the picture. I should look into this. Which one is more accurate? Maybe some other time. And okay, supported by 2 functions to handle the encoding and decoding of the remaining length in the fixed header part. So inside MQTT, I'll use MQTT encode length. Bruh, why? Why? Man, this makes me cry, bro. Like I know when I started C, that they said that you don't really need a name in function prototypes. Sure, compiler won't argue with you over that. But this is just super bad practice, man. Just super bad. Like I know nothing from this. I can get this. What is this? What is this? What is the semantics here? Just makes me cry and makes me angry, bro, at the same time. Like release this packet. You're relying on this, but in case of when you don't have the user defined types, then it is lost. I have to make sense out of reading the whole function. Unsigned char, unsigned short, unsigned char pointer, unsigned it's a back. Now I'll have to go to the implementations and then I'll make sense what is what. Please don't do this, man. Please. Nobody should do this. And compilers shouldn't even allow this at the first place. See, the problem is people do stupid things because you allow them to do. Whoever designed this, or let's just say on the early stage, basically in the end, compiler allowed this, so people do this. Stupidity at its peak. Uh, Mqtt encode length, decode length. Unpack Mqtt packet. Mqtt encode, decode, code length, decode length. Unpack packet, pack packet. So you have one function which will be your Mqtt encode length and decode length. Encode length of what? What is this? Am I supposed to do it? Is the type is this, but what is the name of this? I think I'll have to see the .c file. Encode length. Let's just look for these functions first. So MQTT. To handle the communication using MQTT protocol, we need essentially 4 functions. 2 for each direction of the interaction between packing and packing. Supported by 2 functions to handle the encoding and decoding of remaining length in the fixed header part. Coding and decoding of length. Okay, so coding of length in the fixed part. Okay, cool. So the length encode MQTT encode length. This one. It returns integer and MQTT encode length takes unsigned character means buffer and length. Buffer of what? Where is it defined? Oh god. No way. Standard def? Size T GAD header file CPP reference makes sense if it opens. Defined in header file this C++ even UR type def implementation define size T is unsigned character type of result size of hmm standard def, right? Standard def it is. Initially it was somewhere right in the standard def. Mqtt encode length is done. Then you have this Mqtt decode length. Unsigned long. Like Prime said, we should have never done this naming of data width. Naming of data width or byte width or I don't know, like it is not clear to me from this how long of this width is going to be of the return type. Like integer, I know mostly 4 bytes most cases. What is this? Unsigned 32 64? I think 64 it is. Unsigned long is 64 at least. Versus size T. What is the difference? The downside of replacing size T with unsigned long. What is the difference between this and other unsigned? The difference between size T and unsigned internal 32. I think I should look for size T in CPP reference. Size T is the unsigned integer type of the result of type line of an offset. A line of okay, so depending on data model. What is data model? The choice made by each implementation about the size of the fundamental types are collectively known as. I did not understand a thing. The bit width of size T is not less than 16. But size T can store maximum size of a theoretically possible object of any type. Size T is commonly used for array indexing and loop counting. Programs that use other types, such as unsigned and other, may fail on. Some 64 may fail on 64-bit system when the index exceeds UNT or if it relies on 32-bit modular arithmetic. What? Programs that use other types such as unsigned it for array indexing may fail on. Example: 64-bit systems when the index exceeds. Read the docs and unsigned version of the long data type. Occupies 8 bytes of memory. It stores an integer size. It's 64-bit or larger. Unsigned long is the same as unsigned long int. Its size is platform dependent, but guaranteed by C standard to be at least 64 bits. There was no long in 89, but apparently standard there is no long, though many compilers. Okay, is that the size of these integers are implementation defined? So there's no equivalence without specifying your compiler. You're using the same. Simple type specifier for the type. They are synonymous. CPP reference fundamental types. Target type will have width of at least 64 bits. I was thinking to put size t instead of that, but if it could show me the size t. But like I saw earlier, unsigned integer type of the results are operator as well as unsigned integer type. But the size t is at least 16, so it's only guaranteed that it would be 16. But the benefit of using long is that it's going to be at least 64. But it could go bigger also. That means if I use like 64-bit width, like explicitly specifying uint 64 underscore t, then it is hard coded. It won't. Do I need to think that much right now? I'll just put these unsigned long Mqtt decode and t64 unsigned long. 32 unsigned long. long, long, long. Unsigned long, long, which is synonymous to int, which I'll put int also. It is your constant unsigned character buffer. The pointer would be modified. Pointer, the address of pointer won't be, it's a constant of this type. It would be a constant. Data will be okay. Okay, what do I mean by when I write this unst? This is same as this, right? So constant integer. uh, you are I forgot this. This was very easy. Constant pointer to constant. So this one, constant. It was like weird one was this. It was read. It's read something like this. Constant pointer to constant int. So okay. So when I write this, let's just say then my address of p is constant and the data is not. So I cannot. So I cannot modify the content of p, means I cannot modify the address contained by p. I don't know, man. I forgot. There was something about this. I'll see sometime. It says unsigned constant this whatever pointer to integer, pointer to unsigned character. So it's a pointer to string basically. Use unsigned 64. If it is guaranteed to be 64, I would use fucking 61, and because right now it doesn't matter to me, like w unt 64. Like if this is its at least type, then I would use this. I'm not going to go on some 128-bit machine, right? So this is fine for me. Unsigned long int. Cool. Then you have MQTT unpack packet. It takes your naming of variable is not very good. Yeah, takes your uh, fuck buffer, and then it takes MQTT packet pointer to packet. Cool. Next is MQTT packet unsigned character. Uh, it returns unsigned character, basically unsigned it. It's MQTT packet and then unsigned. It's just this. There is nothing like this. Hi. MQTT. These are static ones, not concerned with them right now. What is this unsigned packet? What I'm unpacking? I'm unpacking. I don't know, man, what this unsigned means. We also add some utility functions to build packets and to release heap allocated ones. Nothing special here. Cool. I'll do that later on the next stream. Like I should put bookmark on here because this is like copy link to highlight and how do I put bookmark here, bro? Uh, we put bookmark like this. I'll know with the where to see. Okay, cool. So we'll see in the next stream. We have to implement these, and this is still a mystery. See ya. Good night.